Good. Now, this is another discussion about immunology, and we have talked about various topics in immunology. We have talked about the overview of immunology, we have talked about the cells of immunology, we have talked about autoimmune and also immunodeficiency. So, today is another day we are going to see about antigen antibody reaction. And in a simple way, what is antigen antibody reaction? What happens if you take drugs and react to them? What happens when you're bitten by a wasp? What happens when you're bitten by a bee? What happens when you're bitten by a snake? What happens if you go to a place where there is a lot of dust and then you start sneezing or you get chest congestion? What is all this? All this is about that antigen antibody reaction. What happens is that when you have a bee biting you, or wasp, or even alligator or anything, that uh, that what is put in your body is antigen, and then your body produces chemicals to fight it, and that is antibody. So that reaction is called antigen antibody reaction. In a simple way, the simplest way, the layman perspective, and that is how it means. So antigen antibody reaction is a reversible, specific, and covalent biochemical reactions where the hydrogen bonds of chemical bond is attracted to an negative atom of another molecule. In that reaction, there is that the hydrogen bond of the listing chemical is attracted to electronegative atom of another molecule in your body. There is electrostatic bond, that is a valence bond in which two atoms attracted by aerostatic forces transfer one or more electrons in between them. There is what is called van der Waals forces, that is the forces acting between non-bonded atoms and molecules. And there is androphobic bonds, that is the attraction forces between molecules due to the crossliness positioning of the androphobic portions of the two molecules, the part of the body which does not have water. So this one can be represented by antigen plus antibody reaction resulting to antigen antibody. And this one can be either two-way. It can be either two-way, and that one K stands for constant association, whereas um, and K2 stands for dissociation. So let us look at the affinity. The affinity is the strength of reaction between a single antigen determinant and a single combining site on the antibody. What does it mean? That the strength, the capability of a reaction between a antigen. A antigen is what is your body gets, that stimulant the body gets with a single combining site in the same which that specific chemical in your body which takes care of that one. So how do they have the strength of the action between them? It's strong, weak, and mild. So on this one, it is associated with a constant binding, uh, which is a constant binding. It can either be constant 1 or constant 2, and that is high affinity. Some cases you'll see that some people will have high affinity, others low affinity. What do we mean with this one? You'll realize that some people will react to something uh, and will cause a severe effect, and others will cause mild, others may cause none. That is in a real way, in a modern day applications, that is how it is. Somebody can get a listing and get a mild reaction. Somebody can get the same big bite and then get a severe reaction. That one is determined by the affinity and by affinity. Oh, the molecule given to the body by the bee able to react with the water to attach to the molecule in your body. The same. So the valency, the number of epitopes, that means the number of binding points is also very important. Affinity is the collective affinity of multiple binding sites. That is an affinity plus valence. So valence is the number of epitopes at what point. So the types of antigen antibody reaction can be either precipitation, can be either agglutination, and also can be either neutralization, that is antitoxins. Antitoxins can be produced, antitoxins can be either endotoxins or exotoxins. So also can be opsonization. Opsonization is something close to phagocytation, where something is engulfed and something is engulfed, something is engulfed, and then it is unable to engulfed, and then it is immobilized and then destroyed. More of what we call phagocytosis when we talk about macrophages. So antibody-dependent cell-mediated cytokines is also another way. Antibody-dependent cell-mediated is another way where the cytotoxic cells causes this one. So the other one is the complement activation membrane attack complexes. So there is, these are the consequences. They can be either neutralize, accreditation, precipitate, or complicate activation, all of them. So in this neutralization is that the virus or the microbe is, or the antigen is neutralized, demobilized. In our conditions, you can see how it is held, and the other one you can see soluble, it's just soluble in the body, and then the other one is complement fixation of activation of complement. This one is realized and then destroyed. So in the precipitate, there is the reaction of soluble antigen with a soluble antigen with a soluble antibody. Then the reaction results in the formation of antibody antigen complexes. Like this one, you can see that antigen, this is the antigen, what is the body is gets, like when you get a bee sting, then the antibodies is what the body produces. Can you see that they are mingling in your body? And then what happens to this one? You can see that there is a precipitate. They are held together and then they precipitate in the body. The other one is quantitative precipitation, is a varying amount of antigen are mixed and incubated with a constant volume of attention. So precipitate is measured amount of precipitate depends on the ratio of antigen to antibody, the antibody ability, and the protein account reasons are detected in this case. So zones of antigen excess, that is result insufficient antibody resulting to so small complexes of precipitate, and equivalent zone like large acids is formed, visceral precipitate is formed, and also zone of antibody excess that not enough antigen result to small complexes of precipitate. So in this case, that is what you can see in the antigen antibody reaction in the three zones. So in agglutinations, this is how it is. You can see the virus there, then the antigens, which are produced by this virus. Those are the spikes. Then you can see the antibodies. They are holding it in place so that it immobilizes it. So our antibodies can bind and cross-link cells or particles, resulting to aggregate formation. So entrap microbes in veins, like microbes, and then agglutinations do happen like red blood cells, immunoglobulin antibodies, and also red blood cells with immunoglobulin antibodies. You can see how they are causing these ones to agglutinate, and they are surrounding these red blood cells. So the applications of agglutination is in agglutination in more agglutinations like quantitative agglutination testing, determination of blood types and antibodies to blood groups, and also quantitative agglutination test. Agglutination test can also be used to measure the level of antibodies to particular antigen. That is titration, like going to test. Passive hemagglutination, that is the erythrocyte are coated with a soluble antigen. For example, a viral antigen, polysaccharide, or aptin, and used the code red blood cells in agglutination to test for antibodies to soluble antigens. So you can see this is that how it works in that one. So the other one is compound test. Antiglobulin test is also very common. And then there is the other process of neutralization. This is the binding of antibody to microbial epitons or soluble molecules, that is examples toxins which inhibit the unbinding to host cells. Antibodies are mostly immunoglobulin A and immunoglobulin G. So used to identify toxins and viruses. Opsonization is the process of which pathogens is marked by target congestion and or destruction of by phagocytic cells. That's what they engulf and destroy and immobilize this. You can see that there is a bacteria there. There is activation of complement system. Immunoglobulin G attacks and then it activates the complement system. The complement system with the FC receptors in the phagocytes, and then it is as the phagocyte then engulfed. It can be engulfed and then the cytotoxic scale can be divided to destroy it. So antibody dependent cell-mediated cytotoxicity is a coating of an organism can attract phagocyte cells as well as cytolytic cells like natural killer cells and eosinophils. So the organism may be bacteria, protozoa, parasitic, or worms. Those are the most common ones which causes this is of the cytotoxic mediated, and these cells use the cytolytic mechanism to kill these microorganisms. So the destruction of larger parasite by this process, you can see that the macrophages and cytokines and lytic enzymes are released. Then favorite and lytic enzymes, like we call them the rhizome enzymes called the hydrolytic enzymes. And then eosinophils, also you can see how it is attacking these larger parasites, then antibodies are produced. So in simple way, that is all about antibody antigen reaction. That is all about antibody antigen